So the exercise, alcohols and carboxylic acid, the structure questions. The alcohols form a homologous series. What are the, give the three characteristics of a homologous series. So you have to learn the characteristic of the homologous series. Like they have the same general formula. They have the same method of preparation. Similar chemical properties. Each member differ by CH2. The following two alcohols are the member of homologous series. Explain why they are isomers. So what is the definition of isomers? Because they have the same molecular formula, but different structures. That's why. Deduce a structure formula of another isomer. Look, if you want to draw an isomer of alcohol, like this is one isomer, this is another isomer, in which if I draw these two, like this is already a straight chain, but if I elaborate this one, so how it is? CH3 is there, CH, CH3, CH2, and OH. So the best way to draw an isomer of alcohol is just change the position of OH. Like as you can see, OH is attached with the first carbon on the right-hand side. So what we'll do, this is butane 1-ol. So we'll just change the position of the OH. Instead of the first carbon, we can place a OH with the second carbon. And it can be placed anywhere. It's not like always with the first one, means up and down, it can be anywhere. So this will become butane 2-ol. So if you want to draw an isomer of alcohol, just simple way, just change the position of OH. But you cannot place at the last because the first and the last carbon are the same one. If I place OH on the left-hand side, the first carbon on the left-hand side, that will also be butane 1-ol. So we have to place from second position to second last position anywhere to form this isomer. In part C, copper 2 oxide can oxidize butanol to. So oxidation of alcohol gives carboxylic acid. Whenever alcohols are oxidized, it will always turn into a carboxylic acid. And what is the oxidizing agent used? So you have to learn this name and the color change for that. So this will be potassium manganate seven. You have to learn this, and when it is used as an oxidizing agent, it will turn from purple to colorless. Which homologous series the liquid X belongs to? Because butanol turned into carboxylic acid, means butanoic acid, so this belongs to carboxylic acid. State the formula of liquid X. So butanoic acid we have to draw. So it will be CH3, CH2, CH2, COOH. Or you can also write C3H7, COOH. Both are correct. You can use this one or you can use the other one. In part D, alcohol, ethanol can be made by fermentation. The yeast is added to an aqueous glucose. The carbon dioxide gas is given off and the mixture becomes warm. As the reaction is exothermic, the graph shows how the rate of a reaction vary over a time. Suggests a method of measuring a rate. So whenever a gas is given off, what we can do, we can measure the volume of the gas in a unit time. So we can measure how much gas is given off. In a particular time, we can identify or find the rate of this reaction. Why does the rate initially increases? So what is the reason why initially the rate is higher? Because as the yeast is used here, So it is multiplying the yeast, the amount of the yeast rapidly increases or the temperature increases. And two reasons why eventually rate decreases, because this is a biological catalyst. Biological catalysts work at a certain time, certain temperature range. So if a high temperature is there, the yeast might be killed off, or because of the high concentration of alcohol, or the amount of the glucose is decreasing. So why does the rate initially increases? What is the reason for that? Because the temperature is increasing. And then why the rate is eventually decreasing? Because maybe enzyme denature. Enzymes may be denatured due to high temperature.
Shut up!
Enzymes denature due to high temperature. That is one reason. And what is the second reason for that? That glucose might be used up. So this was question 1.